welcome to the lecture series conducted by CEC Gurukul. I am Dr. Anuradha from Lady Shriram College for Women, and today I am going to talk about arithmetic mean in detail. Now I will start with the definition of arithmetic mean for a group frequency distribution. So I have said that we can consider a given frequency distribution, which I am denoting it by xi/fi, where this xi/fi have different interpretations when it comes to the discrete frequency distribution and continuous frequency distribution. When it is a discrete frequency distribution, then small xi will denote the value of the random variable capital X, and fi will denote the frequency of the value of xi. And here small n will represent the total number of values of variable x that we have. But when we look at the continuous frequency distribution, then my xi is the class mark of the class interval and the corresponding frequency of the class interval. In that case, my small n is going to be the total number of class intervals. The things will become more clear when I will take up the example for both the cases separately. So, first the definition. X bar is the sum of all the observations. Sum of all the observations here, since x1 is repeated f1 times, so x1 f1 is the total times x1 is coming. Similarly, x2 is repeated f2 times, so x2 f2 is the total number of times x2 is occurring. Similarly, xn f1 is the total number of times xn is occurring. So in the data, this numerator x1 f1 plus x2 f2 up to so on plus xn fn gives the total of all the observations divided by f1 plus f2 plus fn, where this I will represent f1 plus f2 plus fn as capital N, and in the terms of the notation of summation, it will be equal to again summation. We will put f as fi, and then I is going from 1 to small n. I keep on taking the values of I and keep on writing plus 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 and so on. So it is I equal to 1 by it will be f1 plus f2 plus f3 plus so on f small n, which is given by this quantity. So this connection should be very clear. This notation you have to get used to it. We will use it very often in statistics when we do go into the advanced lectures, that how to write from the sum in terms of summation and how to expand the summation and get the expression. These two should be very clear. And similarly, the numerator now is, we are summing, if you look at the ith term of this sum, it will be xi into fi. So that I put here and then take sum will go from 1 to n. So therefore it is now going to become summation I equal to 1 to n xi fi upon summation I equal to 1 to small n fi, which I have said we will always write the sum of all the frequencies as capital N. So therefore this is equal to summation I equal to 1 to n xi fi upon capital N. There is a difference between capital N and the small n that we have used, and this you must have realized by now that what is the difference. So capital N is the total number of observations that you have, because frequency means the number of times a particular value is repeated, and if you sum all the frequencies, that means you are considering all the observations which are given to you. Now next is, let us look at, as I said, let us elaborate it through the example, the calculation of mean of a discrete frequency distribution. Suppose capital X is a discrete variable with the following frequency distribution. Whenever we are given the frequency distribution, we will be given the value of small x's and we will be given the value of small f's. It might happen that you might be given a raw data, and in that case you might be first asked to obtain the discrete frequency distribution. That means you have to obtain these two columns as I mentioned in my earlier lectures, and then you have to obtain the arithmetic mean of that frequency distribution. But here I am directly assuming that we are given the frequency distribution. So capital X is assuming 5 values 1, 2, 3, 4, 5, and the corresponding frequencies are 5, 9, 12, 14 and 10. This x, small x can be anything. It can be 11, 13, 17, 21, 29 and the corresponding frequencies can be obtained or are given. Now what we have to do, x bar is summation I equal to 1 to n xi fi upon capital N, and capital N was sum of all the frequencies. So there are two things that we are going to do. Let us go one by one what we have to do. Here I will obtain a third column. So these two columns, first and second column, are already given to me or we have obtained. We will obtain the third column by multiplying the values of the first column and the second column. So 1 into 5 is 5, 2 into 9 is 18, 3 into 12 is 36, 4 into 14 is 56, and 5 into 10 is 50. I have obtained individually x1 f1, x2 f2, x3 f3, x4 x4 and x5 f5. I have to obtain, after obtaining this third column, I have to obtain now the sum of this third column, which will give me the numerator of the arithmetic mean, which is summation xi fi. And remember, I told you when we have a discrete frequency distribution, then I represents, n represents, small n represents the number of values of capital X given, and here 5 values of capital X are given. So therefore, when we obtain the mean of, we will obtain the sum of this last column, which is the third column, that will give me the numerator, which is summation xi fi, I going from 1 to 5. And then I will also obtain the sum of the frequencies by looking at the column total of the second column, which is 5 plus 9 plus 12 plus 14 plus 10. And this will be my denominator, and then I am going to divide summation xi fi by summation fi. So what I am doing here is, as I had already said in the picture, capital N is the sum of the frequencies. By simple calculation, that comes out to be 50, which is the sum of the frequencies. Then we get to the sum of the third column of the table, which is, I told you, summation xi fi, I going from 1 to 5, which is, I have already obtained them and I am just putting them as sum, and that comes out as 163. Then arithmetic mean of capital X is x bar equal to 163 divided by 50, and which by very simple calculation comes out to be 3.26. Now understand that whenever you have mean or median or mode, they are always of the variable, they are not of a particular value. So that is why I have written arithmetic mean of capital X. Okay, whichever variable you have, arithmetic mean of marks, arithmetic mean of heights, arithmetic mean of weights, whatever capital X represents, it is the arithmetic mean of that variable. It is important to realize this. So 3.26 represents the central value of the frequency distribution of capital X, as which we have treated it to be arithmetic mean. Now let us go on to the next example, that where we are given the continuous frequency distribution. So suppose marks obtained by students in an exam, which we are treating it as a variable x, has the following frequency distribution. So we have grouped the values of capital X and into the 5 class intervals, 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50, and their corresponding frequencies are given. So here your class intervals will be given and your frequencies will be given. So what you have to do is, you have to make 2 more columns now. You have to you have to now here find small xi and small xi fi. Small xi, as I told you, in the case of the continuous frequency distribution, we work with class marks. So therefore you obtain the class mark, and I have already said the class marks are 0 plus 10 by 2, 10 plus 20 by 2, 15, 20 plus 30 by 2, 25. So obtain the class mark from the class intervals. So then we get xi's. After we have got xi's and we already given fi's, now the same step as in the discrete frequency distribution, multiply fi with xi. That means multiply the entries of second column with the third column and write them here, and that is what we will obtain. 12 into 5 is 60, 18 into 15 is 270, 27 into 25 is 675, and like that we go. 8 into 45 is 360, and then we obtain the sum of second column, which will give me capital N, and sum of the fourth column, which will be the summation xi fi. So this is what we have. When I sum the entries of the second column, then my capital N is 100, which is the total number of students whose marks I have considered, and here small n is the total number of class intervals. So there, since we have taken 5 class intervals, so small n is 5. Now multiplying the values of the second and third column and then adding them, we get this as 2590, and then x bar will be simply obtained by 2590 upon 100, and which is 25.9. So on average students have obtained 25.9 marks. Then comes the case that whenever you are given the values of capital X, sometimes the values of capital X may be very large. Large meaning the values of capital X are say 140, 145, 180, 197, 100, 230. When we do that, then the procedure that I have discussed in the just the examples that I have taken, the calculation becomes very tedious and very time consuming if we apply directly the formula. So what we can do is, we can actually effectively change the scale of the observations and then obtain the mean of the original observation in a very using a particular formula, and then the calculation becomes much simpler, and in fact you will be amazed that you can actually do it mentally also. You don't even need to have sometimes a calculators for that. So what we have to see is what we are broadly considering is effect of change of scale on mean. Changing the scale means that you are given the values of xi, right, small x1, small x2 and small xn. I make these values little bit simpler or smaller by subtracting a particular quantity from each of these xi's. So that means what I am going to do is, I am going to define a variable di. What is di? Di is xi minus capital A for all I. So if each observation, each x1, x2, xn that I have, I am going to consider that and subtract capital A quantity from each of them. So this capital A quantity remains same. So that means I am changing the scale by A. So I am just, what I am doing is, I am looking at the ith value of x, which is xi, and subtract A, and this I do for all I. So I will have x1 minus A, x2 minus A, x3 minus A, and so on, xn minus A. In that process, since I have changed my xi's, small xi's, I have to define a new variable which is di's. So this I will call it as di. So if these are di's meaning deviations, because this is like you are looking at the deviation of xi from A. You are subtracting A from each value of xi, and then you are obtaining the value of di. So now what we are going to do is, instead of finding the arithmetic mean based on xi's, I am going to find the arithmetic mean based on di's. Why we do that? Because the values of di's are very simple and very easy and very small, rather than huge or large values of small xi. And then there is a formula which connects the two, and using that I get the arithmetic mean of the original xi's. So arithmetic mean based on original xi's. So let us just proceed one by one. So then instead of xi, we will use di to compute the mean. The arithmetic mean of di will be 1 by capital N summation fi di. Let us try to find what is summation fi di. So this is di. Di is equal to xi minus A. I multiply fi on both the sides. Then fi di will be equal to fi into xi minus A. I open the bracket, then I take the product. So this will be equal to fi xi minus capital A times fi. And now I have got this fi di as this for all I. What we have to do is, we have to obtain this, we have to sum this fi di over I equal to 1 to n. So that is what we will do, and this is what we obtain. So summation I equal to 1 to n fi di will be equal to summation I equal to 1 to n fi xi minus A times summation I equal to 1 to n fi. A is not dependent on I, so it comes out of the summation. That is why I have written it outside the summation. Then this will be equal to summation I equal to 1 to n fi xi minus a times capital N. Remember, summation Fi, which is the sum of all the frequencies, is denoted by capital N. So now my summation Fi di has become summation Fi xi minus an, summation running from I equal to 1 to small n in both the cases. What we need to do, divide just by capital N on both the sides. So I am dividing. Once I divide this, so it will be 1 by capital N summation I equal to 1 to n Fi di by dividing this quantity by capital N, and which will be equal to, I divided by this quantity here also by capital N. So this will be 1 by n summation Fi xi minus a into n by n, that gets cancelled. So I am left with 1 by capital N summation Fi xi I going from 1 to n minus a. And remember, this was the definition of x bar. So therefore this will be equal to x bar minus a. So we got 1 by n summation Fi di equal to x bar minus a. Therefore just take a on the other side. So your x bar will be equal to a plus 1 by capital N summation I equal to 1 to n Fi di. So what it means is, just first obtain di's by subtracting the value of a from each of the xi's, obtain the arithmetic mean of di's, and then add a to it. That will give you the original arithmetic mean. And what is happening here is, the calculations becomes very simple. Let me illustrate this with the help of an example. So suppose I look at a discrete frequency distribution where you can see these heavy values of x's are given and their corresponding frequencies are given. You can already see, if you have to find 137 into 11, you have to do you have to just, it becomes quite big, it becomes 1380, very big values we will get. So instead of that, what we can do is, we can construct a D. Now, how do I take the deviation? By thumb of rule, we generally take capital A to be the middle value of this xi. So there are, say, 5 values, so I am taking the middle value of xi as capital A. Capital A can be any value, it can be arbitrarily any value, but it is comfortable to use 137, you will realize shortly. So I am taking my capital A to be the mid value of these xi's, and which is 137. So what I do is, I subtract 135 minus 137, which is minus 2. 136 minus 137 is minus 1. 137 minus 137 is 0. So from each of the value I am subtracting 137, and see how simple the values have become. They become minus 2, minus 1, 0, 1 and 2. Now what we have to do, these are the values of di. I will now obtain the arithmetic mean of di's. In order to do that, I will multiply Fi into di. I will multiply the elements of the second column with the elements of the third column. So I get Fi di as, you can just mentally do it, you don't need any calculator here. Here earlier you needed a calculator, here you don't need calculator. So it will be minus 8, minus 9, 0, 10 and 16. And in fact, now you need to obtain the sum of Fi di's and you need to obtain the sum of f's, because that is what we do when we want to find the arithmetic mean of di's. And when you do this, it will be minus 9 plus minus 8 plus 10 plus 16, and similarly we will just do that. Then this summation Fi di, by just a simple mental calculation, you get it as 9. And your capital A was 137 and your capital N, which was the sum of the frequencies, is 40. So then my original, see, I am using this di just to find x bar. Please don't lose the focus. I am not trying to find the mean of di's, I am trying to find the mean in terms of di's, because I want to find the mean of original capital X variable. So my now x bar will be capital A, which is 137, plus 1 by capital N, and capital N was found to be 40, sum of the second column, and into summation I going from 1 to n Fi di, where this sum we can see very easily, mentally we can find it is 9. So my x bar is 137 plus 9 by 40, and this comes out to, by just very simple calculation, gives 137.225, which is the mean of x. So whatever is the effect of the change of scale, if we make that adjustment, then it is very simple to see how we can use that effectively to our to our end. We have made our calculations tremendously simple. When we are given the values of the continuous, so I have taken the value of I have considered an example of the discrete frequency distribution. But suppose if I am looking at the continuous frequency distribution, then what we do is we don't change only the scale origin, but we also change the scale. So therefore, let me talk about what is the effect of change of scale and origin on mean. This is generally used when you are given the continuous frequency distribution, and here your A will be again arbitrary, and generally we will take this A to be the mid value of the class mark exercise, and your H is the width of the class interval, and we generally assume it to be same. If the H's are not same, then we cannot then H will be has to be something different, but we will by and large consider the class continuous frequency distribution with the equal width class intervals. So here then in that case my H will be the length of the class interval or the width of the class interval. So I take my here I am changing the scale, that means I am subtracting the value of A from xi, and I am changing the origin, and then I am changing the scale by dividing it by H. So I am changing both origin as well as scale, and let me just elaborate how the calculations become simple in this case. But before that, let me by just following the same set of calculation that I did for the change of origin, we get now the formula becomes this. Here now x bar, which is the mean of the original variable x, will be A plus H by capital N summation Fi di, where this H also comes into the picture. So understand that capital A is an arbitrary value which we am subtracting from each value of xi, and I am dividing this xi minus A by this value H, which is the width of the class interval, and then I obtain di's. Again I obtain the mean of these di, summation Fi di I will obtain capital N, which is the sum of the frequencies, and then put these values and get the original mean of capital X using the mean of di's. So let me go to the example, then things are always simple if you look it through an example. So consider the following continuous frequency distribution of capital X. Whenever I say continuous frequency distribution, you have to understand you are given the class intervals and you are given the values of frequencies. This you will need to always compute. This is never given. The class marks are never given. So I am considering 5 class intervals, 0 to 8, 8 to 16, 16 to 24, 24 to 32 and 32 to 36, and I am looking at their corresponding frequencies which are already given. And I compute my class mark, which I have already said how to compute by adding the lower limit and upper limit and dividing by 2. So I get this as my class mark. Now what I am going to do is I have to choose two things. One is what should be my capital A and what should be my H. H is the width of the class interval. So you can see the width of the class interval is 8. So my H is 8. I am dividing it by 8. And what should be capital A? Capital A should be equal to the middle value of the class marks. So middle value of the class mark here is 20. So therefore it is x minus 20 by 8. That is the operation that I am going to do to obtain D. So therefore what I am going to do is I look at this 4. I will subtract 4 minus 20 upon 8. 4 minus 20 is minus 16, upon 8 is minus 2. Similarly 12 minus 20 upon 8 is minus 1. 20 minus 20 upon 8 is 0, 28 minus 20 upon 8 is 1, and 36 minus 20 upon 8 is 2. So here I end up getting these di's, and now in order to proceed with the formula, I have to find now Fi di. So I multiply the values of the third column with the values of the fourth column and obtain this Fi di. And this is very easy. You can just do it mentally. 8 into minus 2 is minus 16, 7 into minus 1 is minus 7, this is 0, this is 10 and this is 10. And now when you do this simple mathematics, you will see that it will come out to be minus 3. Just add these values because you have to obtain summation Fi di, which is sum of these entries of the fifth column, and summation Fi's, which is the capital N, will be given by the sum of the third column. So therefore, we move on to the next slide. Here we have already talked about capital A is 20 and my small h is 8. So therefore, and capital N, which I said is the sum of the third column, is 40. So therefore, and this is minus 3, summation FIDI is minus 3. So x bar, we put these values here in this formula and it becomes 20 minus 3 into 8 by 40, which is equal to 19 by 0.4, which is the value of mean of x. So this is, if you just follow these steps, you will see that the calculations become much simpler, much easier to handle, and sometimes, as you have seen right now in this example, you can do most of the calculations mentally. Thank you everyone. I hope my lecture will be beneficial for you to understand the concept of arithmetic mean and the effect of change of scale and origin and how to use it effectively for calculating the mean of the given frequency distribution.